Well, teacher, that could be all for my exam. Hope you like my video. See you in class. Bye. After we have understand the things that I told you, then we need to go to our problem. It says a container holds 1,200 milliliters of nitrogen and 49.7 Celsius and the pressure of 1,236 mmHg. What will be its volume if helium temperature increases to 59 Celsius? So then we need to do the formula. 1,000 milliliters under 14, well, would be 85.71. And after we do all that, P equals to 1236, that equals under 700 and under 760. Then we need to do 1.62. The volume, we don't know it. The temperature is 59 plus 273.15. So then for the formula it's 85.17 times 0.082 times 332.15 under 1.62. Then we have the 2,334.42 equals to 1,441 under 1.62. So it could be, for the volume, it could be 1,441. Well, for the ideal gas law, we need the N that equals to moles, the P to the atmosphere is measured, the V for the volume that is equal to liters, the temperature that is Kelvin, we need to add to the Celsius 273.15, and for the R that equals to 0.082. Then the formula is the ATMs times the volume to equals the moles times R and E times 2 the temperature, and that's a multiplication. Then the PV equals to N. So the atmospheres with the volume and the R with the temperature equals to the moles. And then for the volume, it equals, first of all, we need to do a multiplication about the moles, the R, and the temperature under, and then that we have the results of this, we just need to divide it into the atmospheres measure. For the ideal gas law, the N is the moles, the P equals to the atmospheres, the measure at the atmospheres, the volume equals to the liters, the temperature is equal to kelvins, and for a Celsius to kelvins you need to pass the Celsius to plus 273.15, and for the R that equals the and for our last exercise I want to explain first something, so then we can understand it better. So for the ideal gas law, let me explain. First of all, we need to know that the formula is P1 under T1 equals to P2 under T2. Then P2 T2 equals 2 times P1 under T1. Well, let's get started. Well, for P1, here we have the 800 under 760 equals to 1.058 tm. Then for the T1 we have the 377 kelvins. Then the P2 is, we don't know it, and the T2 is equals to 25 plus 273.15, because I explained that every time that we want to convert 25 Celsius to Kelvins, we need to add 273.15, and then we need to add, and then we got 298.15 times 1.05, and the 377 kelvins that we have that there, we need to add here under 377, and then we need to do a really simple math solution, that is 298.15 times 1.05 equals to 313.057, and then we just need to divide it into 377, that equals to 0.83. Okay, Losak, a gas container is initially at 800 mmHg and 377 kelvins. What will the pressure be when the container warms up to room temperature of 25 Celsius?
Exercise number 2, say like
I have done the exercise, but let me explain. Charles' law. Well, first of all, this is the formula. V1 under T1, V2 under T2. V1 equals T1 per V2 times T2. T1 is here, we need to find out that the initial temperature is 35, so we have 35 plus 273.15, so we can change it to kelvins, is 308.15 kelvins. Then we have T2 equals 23.3 plus 35, and it equals 58.33 plus 273.15 equals 331.48 kelvins. So V1 we don't know, that's the volume of the hydrogen that we need to know. Well, for V2 is 485 under 1000 and equals to, let's do this one, and it says 485 under 1000, it equals to 0.485, and then I will explain something real fast. T2 equals 2 because the hydrogen is 2 and the temperature is 35. So first we need to do this. 70, 35, 2 times 35, 70. And under 3, then we need to do it 70 under 3 is 23.33. So V2 for V1 the formula is 308.15 kelvins times 0.485 liters, and under 331.48 kelvins. So there we go. So let's do the fast. This 308.15 kelvins times 0.485. So this equals to 149.45 times 331 0.48, and this equals to 0.45. So the result for the volume of the hydrogen is 0.45 Celsius.
Hi teacher, this is my exam. So the first problem is Charles' law. Sample of hydrogen has an initial temperature of 35 Celsius. When the temperature is increased 2/3 of the initial temperature, the volume of hydrogen becomes 85 milliliters. What was the initial volume of the hydrogen? Well, so there we go.